Okay, so let's go ahead and we're going to go over 3.2, which is graphs of rational equations, part 1. I'm actually kind of merging these together, though, so that I don't know if there's really going to be a part 2. But here we go. Okay, so if you're given an equation of the form f of x is equal to p of x over q of x, where p of x and q of x are both polynomials, and the degree of the top is m. Okay, so we have the degree here is equal to m. Remember what degree is? Degree is the highest power in that polynomial. So I'm just saying assume m is the largest here. And then the degree of the numerator or the denominator is equal to n because n is going to be the biggest. Then we have a couple of things that are going on here. If the degree of the top is more than the bottom, then there is no horizontal asymptote. Okay, there's not going to be one. If they're equal to each other, then what you're going to do is the horizontal asymptote is you're just going to take whatever the leading coefficients are, and that's going to be the equation. Or if the degree of the top is less than the bottom, then it's simply going to be y is equal to 0. Okay. Now, where are their vertical? So those are horizontal asymptotes. Now, where are their vertical asymptotes at? They're vertical asymptotes where q of x is equal to 0. Now, I also should put in there you can have holes. They're vertical asymptotes / holes. Sorry. Okay. So let's go ahead and go over this. So the first thing I want to do is I want to figure out what the degree of the top is and what the bottom is. If you notice the degree of the top is 1, the degree of the bottom is 1, and so we fit into this category of m is equal to n. Okay, so because of that, the horizontal asymptote is just going to be you take the leading coefficients. Well, there's a 1 in front of that x, there's a 1 in front of that x, so the horizontal asymptote, I'm just going to put as HA, is y is equal to 1 over 1, which is just 1. Okay, so what I know is I have a horizontal asymptote here at 1. Okay, what about a vertical asymptote? Now, a vertical asymptote occurs where the denominator is equal to 0. So what I'm going to do is I'm going to set it equal to 0 and I'm going to solve. So I'm going to add 2 to both sides. I have x is equal to 2. So x is equal to 2 is the vertical asymptote. Now, when you graph these, typically, not always, but typically the graphs of these are going to be kitty corner from each other. They're either going to be up here and down there or up here and down there. Okay, once again, the graphs will normally be kitty corner from each other. So they'll either be down here and up there, or they're going to be up here and down there. So how do you do this? Usually the best way to do this is to find the y-intercept. So I'm going to find out where it lies on this line. If it lies down here, then the graph is going to be there and there. If the y-intercept falls up here, then the graph is going to be there and here. So I'm going to make x equal to 0. So making x equal to 0, f of 0 is equal to 0 over negative 2. Just plug it into this equation, which is equal to 0. That means it passes through the point right there, which means the graph is going to go right here and up there. Okay. It's important to point out that these dotted lines are not part of the graph. They're just there to help us create the graph. Okay, so right here, graph this equation and determine the vertical and horizontal asymptotes. Once again, the very first thing we do is determine what the leading coefficient is going to be. So the degrees are going to be. So this is a power of 1. That is a power of 1. So once again, I fall into this mode right here. M is equal to n because the powers are equal to each other. And so when I do that, then the horizontal asymptote is just going to be whatever these leading coefficients are. So 3 over 1. So I have y is equal to 3 over 1, which is just 3. So that is going to be the horizontal asymptote. So 1, 2, 3. Okay, then I have to do the vertical asymptote. And the vertical asymptote is determined by taking the denominator and set it equal to 0 and solve. So you go x plus 5 is equal to 0, minus 5 minus 5, x is equal to negative 5. So I come down here, I go back 1, 2, 3, 4, 5. So it's going to be like this. So once again, the graph's either going to be down here and up here, or top left and bottom right. So what do? You plug in 0. So f of 0 is equal to 3 times 0 minus 2 all over 0 plus 5, which is equal to negative 2/5. So that means the y-intercept is negative 2/5. It's going to be down here somewhere. So if you look where these asymptotes are, that means my graph is going to be here and up there. Okay, these two places. So the graph is going to come up and go like this and go like that. Okay, next page. Okay, next one. So graph the equation. This one's a little bit different because this is actually what creates a hole for the first time. Okay, so here's what we do. If you notice the bottom, you can factor the bottom. So I'm going to go f of x is equal to x minus 3 all over, what are the factors of negative 18 that add up to positive 9? And I didn't do that right, did I? No, I did not. I meant to change this. This is supposed to be a 3. Okay. So anyway, sorry. So what are the factors of negative 18 that add up to positive 3? The 6 and negative 3. Those two multiply to be negative 18, but add to be positive 3. So I'm going to factor the bottom into x minus 6 times x plus 3. Sorry, minus 3. It's x plus 6, x minus 3. And then what do you notice happens? These actually cancel, and I'm simply just left with 1 all over x plus 6. Okay, now I do the same thing I did on the other side. So what is the degree of the top? Well, this is x to the power of 0, so the degree is 0 here. The degree on the bottom is 1, and when the degree of the bottom is more than the degree of the top, then my horizontal asymptote is always y is equal to 0. Always. Okay, let me restate that. When the degree of the top is less than the degree of the bottom, then it's going to be y is equal to 0. Okay, now I need to look for the vertical asymptote. Now here's where it's a little bit different. Okay, for the vertical asymptote, I'm only going to look at that portion. That's what's going to tell me. Okay, so what I do is I say x plus 6 is equal to 0, minus 6, you have x is equal to negative 6. Okay, so here's what I noticed so far. I know there is a horizontal asymptote at y is equal to 0, which is right here. I know there is a vertical asymptote at x is equal to negative 6. 1, 2, 3, 4, 5, 6. So the graph is either going to be down here and up here, so there, or there and there. Now you have to remember, there's still one thing I have to go back and do at the end here. Okay, there's one thing. So what do I do normally? Now I plug in 0. Plugging in 0 to this equation here. I don't need to look at this one anymore. I'm just going to look at the reduced one. I have 1/6. If you plug 0 into that equation, you just get 1 over 6. So that means 1/6 is right there. That means the graph is going to come down and go like that. And it's going to go like that. Now, what about this negative 3? This right here, this x minus 3, that's what creates a hole. It's no longer a vertical asymptote, it's a hole. You cannot plug 3 into this equation because it will make the denominator equal to 0. Everything else is going to be the same. You just cannot plug in 3. Right? How do I know it's 3? Because I know that that thing can't be equal to 0. So if you go x minus 3 is equal to 0 and you add 3 to both sides, you get x is equal to 3. Okay, so here's what you do with this. Here's how you handle it. You go over to 3, 1, 2, 3, and you draw a hole there. Okay, this hole is representative that you cannot plug in 3 to that equation. Okay, so that's where we are. Let's go ahead and try this one now. This one right here, we need to factor. So I have x plus 3. Factors of 15 that add up to positive 8 are 3 and 5. So this is going to be x plus 3 times x plus 5. And once again, you notice those cancel. So this is equal to 1 all over x plus 5. Okay, the degree of the top is 0 because there's nothing there. The degree of the top or in the bottom is 1. So the degree of the bottom is more than the top. So therefore, there's a horizontal asymptote at y is equal to 0. Okay, furthermore, I know that there is a vertical asymptote at x is equal to negative 5 because I know if I plug negative 5 into this, it will make the denominator equal to 0. So y is equal to 0 is right here. X is equal to negative 5 is back here. And now my graph is either going to be down below to the left, down left, or upper right, or upper left and down right. So what do? We plug in a value of 0 for x. It doesn't have to be 0. Usually 0 is the easiest thing to plug in. So when I do that, once again, I'm going to go to this equation right here. So I have 1/5. So at 0, you're at 1/5. It's right there, which means my graph is going to go right here, and it's going to go right there. Now, are there any holes? And the answer is yes, because I canceled it out. So what is the value of x that will make this thing equal to 0? Hopefully you see it's negative 3, right? Negative 3 plus 3 is equal to 0. If you don't see that, you can just say x plus 3 is equal to 0. Subtract 3 from both sides, and x is equal to negative 3. So I go to negative 3, 1, 2, 3, and there's going to be a hole right there. Okay, so ignore that thing right there. The graph actually goes right. It does not go through that point. Okay, the next one. Now, the next one, if you notice, this graph, this equation is the reciprocal of this, right? This equation is just the flip version of this. So I can factor the top into the same thing, x plus 3 times x plus 5, and once again, those cancel. So now my equation just becomes f of x is equal to x plus 5. There is no vertical asymptote. There is no horizontal asymptote. That is just the equation of a line. So 1, 2, 3, 4, 5. It has a slope of 1, so the graph goes like this. However, it still has a hole. And it has a hole at the place where I canceled it out, which is x is equal to negative 3. So if I go to negative 3, 1, 2, 3, there's going to be a hole right there. And that's what the graph of it looks like. Okay? And then the last one here, so let's go ahead and factor an x out of the top. So factor an x out of the top. I have x times x plus 3. And on the bottom, what are the factors of 6 that add up to positive 5? Well, that's 2 and 3. So I have x plus 2 times x plus 3. Once again, those cancel. And I'm left with x all over x plus 2. So the degree of the top is 1. The degree of the bottom is 1. Since those are the same, the leading coefficients, which is 1 over 1, is going to be the horizontal asymptote. So there's a horizontal asymptote at y is equal to 1. Furthermore, I'm going to look here for the vertical asymptote. And as you see, if you plug negative 2 into this, because this is x plus 2, if you plug negative 2 in there, it's going to make it equal to 0. So in other words, the vertical asymptote is x cannot be equal to negative 2. Sorry, it's x is equal to 2, because negative 2, because it can't be equal to that. Okay, so once again, go down below, graph my vertical or my horizontal asymptote of y is equal to 1. Graph my horizontal asymptote or my vertical asymptote of x equal to negative 2. So the graph is going to be down left or up right, or up left and down right. So what you do is you plug in a value for x, which in this case the easiest to do is 0. And when I do this, I get 0 over 2, which is equal to 0. That means it goes right there through the origin. So my graph is going to look like this and like this. Now, I need to account for the fact that it has a hole. Now, where does it have a hole? It has a hole at the place that I crossed it off. So I'll go x plus 3 is equal to 0. Minus 3 minus 3, I have x is equal to negative 3. So at negative 3, it's going to have a hole. So negative 1, negative 2, negative 3. So up here, it has a hole. Okay, and there we are. If you have any questions on this, please let me know, and I'll do my best to help you out. Okay, thanks, everybody. Take care, and we'll see you later.